All right, so today we're going to look at section 2.4, linear function forms. These are the three forms that the linear equations come in. And so here we go. Let's list them all out. The first one is a general form. Sometimes they'll call it the standard. So depending on what textbook you use and stuff like that. And it comes in the form of ax, ey equals c. A, B, and C are unknowns. These are just numbers. X and Y are the variable. And this equation type is used in many real-world problems. A lot of times you'll use this format, and when we start doing any kind of real-world problem, it's usually going to be in this form that we're going to use. Okay? Some purposes for it. Can be used to find the X and Y intercept. And I'll talk about what that is right now. When I graph a line, any line, with the exception of the two special cases we'll talk about later, this is the x-axis, this is the y-axis. If I draw any line anywhere, any direction, it doesn't really matter which way I do it, so I'll just default to this one. So here's some line. The line is going to cross both the x-axis and the y-axis. Where a graph crosses the x and y-axis, we call those the x and y intercept. The graph is intercepting the y-axis at that point. The graph is intercepting the x-axis at that point. So these are two special spots of points that we want to find on our graphs many times. And so the rest of the math that you're going to do, the y-intercept has a certain meaning and context. The x-intercepts have meaning in certain contexts. And so we want to be able to find those values if possible. So this is an x-intercept and a y-intercept, and that's what they mean. Because they land on these axes, we already know certain things about them. For example, a y-intercept always has a 0 for the x-coordinate because it's on the y-axis and x is 0 there. And the y, they just usually use the letter lowercase b for a y-intercept. An x-intercept has a special characteristic, and that is the y value is 0 because the y value here is 0. And they use the letter A to usually represent the x-coordinate for that point. So a y-intercept and an x-intercept, and these are the letters that they usually use to represent them. And you'll see those letters pop up quite frequently in other areas about what we're going to be talking about. So those are what x and y-intercepts are in a graph. This format right here, I use this format. If I have it, I can find the x and y-intercept fairly easily with that by simply making a table for x and y, and you just plug in 0 for x, and I will get the y-intercept. And if I plug in 0 for y, I will get the x-intercept. So you just make a table. You plug in this number, the 0, for x, and you'll get the y-intercept. If I plug in 0 for y, I'll get the x-intercept when I solve that. That's kind of how it works. And the next one I want to look at is the point slope formula. And that is this one right here. And when you look at it, you're going to see hopefully you'll see some very interesting things that we did. So this is what it looks like. A point slope means I need a point, which they call x1, y1, and a slope, which they use for m. This is the slope, and this is the point. The x and the y in this are the variable. These are the letters that stay in the formula itself. It's the x and the y of the formula. The purpose of this thing right here, and you're going to use this quite a lot, its purpose is to write an equation. of a line. Anytime you are asked to write an equation of a line, this is the formula you're going to use. You can do it other ways too, and I wouldn't mark you wrong if you use the other ways properly, but this is the one that you want to use from this point forward. If you look closely at it, because it looks very similar to the formula we had for an arithmetic sequence. If you remember the arithmetic sequence, we use what? A sub n equals what? A sub 1 d times n minus 1. D was the common difference, so d and the rate of change serve the same purpose. Here we have a 1 and an a sub 1, and a sub 1 is the first number in the sequence, so the first number in the sequence was a sub 1. That's the point, the first number in the sequence. So that's where this comes from. It comes from the point slope formula for finding equations, which are literally rules. Okay? So the purpose of the point slope again is to write an equation of a line. The third form is called the slope-intercept form. The slope-intercept form is when I take an equation and I have it set equal to y. So y equals, and I will get mx plus b. When we solved this out and simplified it, we got an a sub n equals. It's basically that format right there. This shows you exactly what it says. You can look at this equation and see this slope and the intercept. Well, what intercept? What do we call b? The y-intercept is what we call b. This is the y-intercept, and this is the x-intercept. So m is the slope, and b is the y-intercept. So you can look right at the equation and tell those two pieces of information when I have it equals y equals format, the slope-intercept form. So these are the three forms you're going to be asked to use and do in problems. This one, you can use this to find an equation of a line, provided you know the y-intercept. Okay? When I use the y-intercept x is 0, right? So it's just this format here where x is 0. But that's what it means. I strongly recommend that anytime you're asked to write the equation, you always use this one no matter what point is given to you. Don't learn multiple ways of doing something that you don't need to. Okay? Use that method. The next thing you're going to be asked to do is graphing. Graphing in linear functions. Here's the thing that you need to remember. When you graph, you're going to make a table. That's what you're going to do. Okay? We're not going to do any tricks for graphing and all that kind of stuff that they show in other classes and stuff like that. There's no reason for it. Once you learn how everything works and all that kind of stuff, all the tricks are quick ways to make a table. That's all they are. Okay? When you graph beyond this point, you make a table. That's how you graph. So that's what you're going to do. You're going to get used to making a table. Since we do everything by making a table first, it shouldn't be that hard to do. You need to make a table. With 3 points in it. Two to draw the line. And the third to check. If all 3 points line up, you know you got it right. If 1 point doesn't line up, you got something wrong. Stop, go back, reevaluate your points, make sure you have them done correctly. This is why we make a table. Okay? Almost all points, every point in the table, every time you make a table, you want to try and find the y-intercept because it's easy. You can plug in 0 for x, and you get the y-intercept. You don't always find the x-intercept, but in a table, you always do the y-intercept. I recommend, now if you can, do both because it's easy. If I have this format, I'll do both, x and y-intercept, because it's real simple. Plug in at 0 each time. But if I have this format right here, I don't always plug in 0 for the y and solve that. I'll always plug in 0 for x and get the y-intercept, which is sitting right here. Okay, and then I'll just plug in other numbers. And if I happen to get an x-intercept, so be it. If not, then I don't really care. Other things about graphing. Plug in a positive number, a negative number, and 0. When you're graphing, plug in a positive number, a negative number, and 0. Don't do all positives. Get a nice spread of your graph. Okay. That'll fluctuate. This is not a hard, fast rule, but it's just the general trend that you always want to try and do. Try and plug in when you do an equation graphing. You plug in negative numbers, positive numbers, and 0 all the time. Okay. So that's what I'm going to be looking for. Think about the numbers you choose. There's 2 of them. Try to avoid fractions if possible. It's easier to graph integers than it is fractions. Okay? And we'll show some examples that might help you understand what I mean by that. Don't forget our special lines that we need. Special lines. You're going to be asked to write equations of lines. So your special lines are your vertical and horizontal. Your vertical line is the equation x equals a. That is a vertical line equation. That's how you write it. YA, there's a reason why they use A. A vertical line is a line that goes through the x-axis only. It only goes through the x-axis. That's why there's only one letter here. If you ever wanted to know why, this one has 2 letters, an x and a y, because all other lines will cross both the x and the y-axis. So it has 2 letters, an x value and a y value. But a vertical line only crosses the x-axis, so it only has the equation x equals, and wherever it crosses the x-axis, that's the name of the line. Only x is a. Every point on here has an a for the x coordinate, and only the y values change. And likewise for the horizontal line. The horizontal line only crosses the y-axis, so it has the equation y equals b because it has only a y-intercept, so we use the same letter, and it only goes through here, and all the y values on that line are b, and x's change. So y equals b, x equals a. These are your 2 specialty lines. You want to make sure you just memorize those. And remember, we talked about slopes. This one has no slope, and this one over here has the slope equal to 0. So some things to remember from before. So that's it. We're going to do some examples now, some things I want you to see how to do. I'll put these 3 examples in our video here so you can see them and how we use the different forms to do different things. So the first question I want to do is this right here. Here's an example. I'm going to give you y equals -3/5 x plus 3. So in looking at this, we can see that this graph is written in slope-intercept form. When it says y equals, that is slope-intercept form. And from this equation alone, we can identify both the slope of this line, the rate of change, and the y-intercept. It's written for you right there in plain sight. Your slope is going to be a negative 3 over 5. It is always the number right in front of the x. Wherever the x is, the number in front is your slope. So even if it's written weird, the number in front of the x is your slope. Your y-intercept, we can just call it b, because we know the y-intercept is using the letter b to designate it, is this number on the end. Take the sign with it. So plus 3 means we have a y-intercept at 3. As a point, it would be the point 0 on x, 3 on the y. That's what it means. Once you understand that, then we can graph this also. How do I graph this? Again, make a table. Don't overthink it. How many points do I need in my table? I need to have 3 points, one of which is going to be 0. But I already know what that is. It's the y-intercept, so I have that point already. I have a slope, which is a change in the y's over the change in the x's of a negative 3/5. So that means going this way, I need to do something, and going this way, I need to do something. You can take the negative with either the top number or the bottom number, but don't mix it up. Once you choose, you've chosen. So if I move the negative to the top, which is usually what people do, that means the change in the y's has to be minus 3, so I have to go minus 3. Which means the x's has to be plus 5. Negative 3 over 5, you see? That's how we use our slope, right? So if I subtract 3 from 3, I get 0, and if I add 5 to 0, I get 5. And then this number from here to here had to be a subtract 3, and from here to here had to be a plus 5. So what number minus 3 gives me 3? 6. What number plus 5 gives me 0? I can use the slope to help me make this table, can't I? So that's one methodology for finding your table. Another way to do the exact same thing, if you didn't want to do this approach to it, is simply zero always is in the middle. Just pick a number. Now, why is this a better one? Why would I pick 5? Remember in that little note I said try to avoid fractions. My slope is a fraction. If I pick the number 1, I'm going to get a fraction in my answer. Now, that's fine if you want to work with fractions. There's no problem with it. Go right ahead. More power to you. But if you don't want to work with fractions in your answers, then you need to pick a number that will divide by 5. And the first number I would pick would be 5. So I'm going to say, oh, I'm going to pick 5. All right, well, then what do? Well, then I go on my scratch paper and I write this out. Y equals a negative 3 over 5 times 5 plus 3. And I work that out. 5 divided by 5 is 1. And I get negative 3 plus 3, which is 0. And I got a 0 sitting right there. So you just plug your number into your equation to get your y value. But we knew this already. I'm just showing you that I get the same answer either way. Graphing. How can I use the slope? Now, I have the table. I can just put the dots on the table. Ever see this? So if you make the table and you do it, then whether you made it this way or you made it this way, it doesn't matter. I need one more point to check it. I know what the point is. Negative 5, 6 is what I got from that table up there. And I just put the dots and I draw my line. I'm done. Okay? I'm going to show you how I can make the table in my picture at the same time. So some people learn this in other classes and they spend like 3 days on this topic, but really you don't need to for graphing. I know the y-intercept is 3. I see that from my graph, my equation right there. I can go to 0, 3 and put a dot. That is one dot on my graph. And so like I did over here where I used the slope to find another point on my graph, correct? I can use the slope to find another point on my graph from here. In the form of what? Use rise over run. And I showed you that technique in the last lesson. Well, that means from here, if I go up or down, or whatever it is, we have a -3/5 is my slope. As a rise, that means to go down 3. So from here, if I go down 3 units, and then run 5 is positive, that's this way, 1, 2, 3, 4, 5, that is another point on my graph. And I did a slope of down 3 over 5 plus 5, which is exactly what we did right here. We went down 3 and over 5. It's the same thing. Well, how do I get this point? Well, just do the same thing, just go in the opposite direction. Remember when I told you that I can put this as the top, the negative with the top, or the negative with the bottom. If I'm doing rise over run, there's some point over here where I go down 3 and over 5, so just go in the opposite direction. From here, go up 3 and to the left 5. This point we can see is 5, 0. This point is 0, 3. And this point right here is up 3. So now I'm at 6 and back 5. That's -5. And that's the point we have right there. And they all line up. If they all line up in our line. 3 points to check. 2 to draw, 3 to check. 2 to draw, 3 to check. If they all line up, you know you got it right. And so that's how you can do rise over run to find points. That's how I can do plug in 0, either one. Use the slope to help me find it using the table concepts. Whichever way works for you is fine for me. The point is, you need to graph a line. And you need 3 points to do it. You can avoid fractions if you have them in your slope by picking numbers that will divide by the bottom. And then you'll get whole numbers and no fractions, okay? That's that one. Here's another example you'll be asked to do. In this case, I'm going to give you these 2 points right here, -4, 12, and -7, -3. Now, that's 2 points I gave you on the line, so I can draw the line right there and there. I'm not finding the points. They gave me the points. There they are. I don't need 3 because they told you those 2 points are on it. You have 2 set points. You can draw the line. But what they want you to do is write the equation. So if I want to write the equation of line, I need 3 things. A point, of which I have 2. A slope, which I don't have. And the formula that I'm going to use, which is the point slope formula. And you should write it down every time. It will help you memorize the formula. I need that, and I need a point and a slope. I have 2 points. I'll get to that in a minute, but I need the slope. How am I going to find the slope? We have many ways to find the slope that we've talked about in the past already. My recommendation is to put your data into a table real quick. I got -4, 12. I got -7, -3. The order in which the points go into the table did not matter. Just put them in there and tell me the rate of change in both directions. From here to here, I'm going to go minus, looks like 15. From here to here, I'm going to go -3. So my slope, which is the change in the y's over the change in the x's, is -15 divided by -3. And then you reduce that, and you get a slope of 5. All you need to do now is take that slope and pick any point. It does not matter which point you pick. You'll get the same answer either way. I'm going to use the negative ones over here because I want you to be careful of how you plug it in. When you plug numbers into this formula, always plug them in using parentheses. The y1 and the x1, use parentheses with it. So y minus the y1, the slope is a 5, x minus an x1. If I use this point, that's -3, and that's -7. If you don't do this, you have a run the high risk of getting sign errors. Clean up these signs. So this would be y plus 3. This would be x plus 7. So unless they tell you how to write the answer, that's correct. You can stop. A lot of times they'll ask you to write it into slope-intercept form, which means you need to make it say y equals. To do that, you'll need to distribute this. That's 5 times x, and then plus 5 times 7. Then you're going to move the 3 over by subtracting 3 to both sides. And you'll get y equals 5x plus 35 minus 3, 32. And that's the equation there. This is an equation, and so is that one. So depending on what form they want your answer in. So this is what you'll be asked to do there. The third example I want to go through uses this equation right here, which is in general or standard form. And usually when they give you this one, it's about find the x and the y intercept. And we already talked about how to do that. You simply do what? Don't waste time solving for y to get the y-intercept. Just make the table. You plug in 0 for x and 0 for y. And then you work them out. Start with this one. If x is 0, then I get 3 times 0 minus 4y equals -24. 3 times 0 is 0. If you know how to solve this, fine. If not, I didn't really talk about how to solve this yet. But what number times -4 gives me -24? And hopefully you can see that that number is going to be a 6. You can also do it by simply dividing both sides by -4. Same process for the other one. 3 times x, 4 times 0, -24. 3 times what number is a -24? Hopefully you can see that that number is going to be a -8. If not, just divide that by 3, and you get that, and you get -8. And those are your two x and y intercepts. So if I wanted to graph that, I just need one more point, and you can pick any point you want. Right? It really doesn't matter. So those are the two things right there that we're going to talk about. Those are the different kind of questions you're going to see. You now have those in your little notes. I want to look at one more. I'm going to look at problem number 42 on page 74. Another use for the general form. I'm going to show you this problem. This is a real world scenario kind of a problem. Number 42 says Gregory can buy 4 pounds of wheat flour for $8 and 5 pounds of rye flour for $20. He has $12 to spend on flour mixture. What linear equation in standard form can Gregory use to model this situation? Okay, so how do I go about doing that? So he's going to do a mixture of things, and he has $12 to do it. This is the kind of problems that you will be dealing with in the linear problems. So if we look at that, we have a couple things. So when you do this, organize your information, gather your thoughts about what everything is talking about. So we have a couple of things. You get 4 pounds. So just write down what you know. You get 4 pounds for $8. This is for wheat. You can get 5 pounds for $20, and that is rye. He has $12 to spend. Spending money. And you're going to get some of each. Okay? It says write a linear equation in standard form. That's the general form. Okay? That's the AX BY equals C format. So how can I get this information into this format? So let's talk about it. We have unknowns, A, B, and C. These are numbers or things that represent quantities that don't change in this problem. Now, they'll change between problems, but in this particular problem alone, these numbers will be fixed. They're going to be a number, but it's going to be fixed, like a 3 or a 5 or something like that. The X and the Y represent things that change. Those are variables. A, B, and C are unknowns. X and Y are variables. If I'm going to put stuff into another big bag, a combination of wheat and rye flour, something's going to be changed here. So visualize this happening at the store. If you go to a store, visualize, put yourself in the story. If you go to the store and you buy something, based off of how much you get. Like if you go get have you ever been to a bulk store place where you just you can get like bulk beans or bulk rice, you just scoop it into a bag kind of a thing. The price is fixed, but the amount you get varies. So how much you get, the weight, or how much you get varies in this situation, but the pricing is going to be fixed. Your pricing is 4 pounds for $8. Well, I can write that as a rate, can't I? 4 over 8. So this is kind of like your rate of change kind of a thing. If 4 pounds is $8, then what is 1 pound? So 1 pound is $2. So 1 pound is $2. And I can do the same thing for this. If 5 pounds is 20, then 1 pound is how much? $4. I want to put some wheat and rye into a bag. Okay? The prices don't change based off of how much I get. So the only thing that's going to change is how much I have. This tells you then that the variables, the things that change, are how much I have. So then you write down that X represents the amount of wheat flour in pounds. Y is the amount of rye flour in pounds. When I buy something at the store, it gives me a cost. If I want to buy 1 pound of wheat flour, it's going to cost me $2. If I buy 2 pounds, it's going to cost me $4. The A number here, then this quantity right here combined, if that tells me how many pounds I buy, then to get a dollar amount from that, I have to put a dollar amount for the A, a fixed amount. It's is $2 per pound, and X is the number of wheat in pounds. So I can get a price for wheat alone. If I use $2 and X, this means the price of X pounds of wheat. So then what does that mean? It means the same thing, but for the other item, the rye. Rye is $4 a pound. $4 a pound, that is the rate. So then Y, if Y is the amount of rye in pounds, then $4 times the amount is my price of Y pounds of rye. That quantity is how much it costs for the wheat flour. That quantity is how much it costs for the rye flour. If I put them together, then I have a cost or the price of both of them combined. But I only have $12 to spend. So I want to limit that amount to $12. This is a price. This is a price. This is a price. This is money, money, and money. That's why this equation would be this right here. This is how much money I spend on wheat flour. This is how much money I spend on rye flour. And this is how much money I have to spend. And I want both sides to be the same. And so that is how I can use the general formula or standard formula to write a model. This takes practice, but it's all pretty much formulated. It's kind of standard fare, but you have to understand the question and how things work. And the best way to do that is to be the person in the store buying it. See the story in your mind. Be the guy in the story. Then it's much easier. Most people can go to a store and buy things. If I say you only got $20 to spend, I want you to go buy me some milk and some bread. And until you spend as close as you can to $20 without going over, everyone in this room can go do it. Hardly any problems whatsoever. But if I give you the same scenario in a story problem like this, then everybody freaks out. They don't know how to do it. It's because you're looking at it as a math problem instead of a real life problem. You can do this. You just got to think about what you're doing in context to you being in the story. Okay? It does take practice, but this is how you can use this to solve this. All right. I'm going to stop the video here, and we'll take other questions off.